Hi everyone, so we have this problem which is about heat, energy, and specific heat. It says, if you pour 200 grams of water at 50 degrees Celsius into a container with 100 grams of water at 20 degrees Celsius and seal the container so no heat escapes, what is the final temperature of the water? So two things to point out. First, we're sealing the container so it doesn't have any interaction with the energy outside of the container, meaning everything is going to happen inside of the container, so we can justify conservation of energy and without any dissipation of energy. And we need to find the final temperature of the water. So we're going to have heat and change in temperature. So we have to use the equation we learned for specific heat. Now, this is not that simple because some students will say, well, I can just get the difference in temperature from 50 to 20 and combine the masses and that's it. But that's not really how you solve this one because you have a two-part system. So you have to take into account the heat exchange. And it's simple. It's not that hard because the heat lost by the water with higher temperature will be the heat gained by the water with the lower temperature. Okay, so we could describe it like this. Before we even start with our given, let's define that heat exchange. So the heat lost by, wait, it's not heat, I meant to say hot, for higher temperature, right, will be the same as the heat gained by the cold water. In this case, we have the two-part system, the hot and the cold, okay? We're just using hot and cold to help us distinguish between these two parts of the system, which means well, now we need to label our setup, or what we'll identify as the hot setup, meaning everything that has the higher temperature. This is what I mean. We'll have, let's do it over here. For hot, we'll say that the mass is mass 1, and that'll be 200 grams of water. Let me do that number 2 again. Well, the whole thing, right? There you go, it's a little better. And we're going to have the temperature, in this case is the initial temperature. So I'm going to write it as T1I for initial. That'll be 50 degrees Celsius. And then for the cold setup, we'll have mass 2, which is 100 grams, and temperature to initial will be 20 degrees Celsius. There you go. Now, specific heat. Well, we have water for both parts of the system, so we can say specific heat 1 for the hot setup is the same as specific heat 2, which we can just call specific heat with no subscript. So then we can now write our equation, because we know the general equation is heat equals mass times specific heat times change in temperature. Let's do that equal sign again. So we can say mass 1 times specific heat times change in temperature 1 equals mass 2 times specific heat times change in temperature 2. Notice how we can cancel specific heat. So now we have mass 1 times delta T1 equals mass 2 times delta T2. And the rest is algebra. So I'm going to use the right side of the page to work this out, because we need to, since we're looking for a final temperature, right? in this case, let me write over here, the final temperature will be the same. We don't have to label 1 or 2 because it'll be the same, right? They're trying to reach thermal equilibrium, having the same temperature. So the temperature final, it's going to be the same because we're combining the water. Okay, so now we can say mass 1 times, well, before I write this one, I should have said this before. Since the 200 grams of water are at 50 degrees Celsius and the 100 grams of water are at 20 degrees Celsius, then the final temperature, it's going to be below 50 but higher than 20, somewhere in between, right? Because the 50 degrees are going to exchange heat, so they're going to add heat to the 20 degrees so that you reach thermal equilibrium, meaning the final temperature, well, the initial temperature of the water on the cold setup, so T1I, will be greater than the final temperature of the water. And the final temperature of the water will be greater, let's try that again, than the initial temperature of the water at 20 degrees. Again, that's because the water is going to reach thermal equilibrium somewhere in between 50 and 20, right? So now, let's work this out. Check it out. Mass 1 times, now for the change in temperature for the hot setup, since the initial temperature, which is 50 degrees, will be higher than the final temperature, we'll write temperature 1 initial minus temperature final equals mass 2, and then now we'll do the opposite for this one. Temperature final, which will be higher for this one, minus temperature 2 initial. And then we just do a very simple version of FOIL, right? So multiply the mass times both temperatures on both sides. So we'll have M1, temperature 1 initial, minus M1, temperature final, equals M2 times temperature final, minus, forgot to write mass 2 times temperature 2 initial. Okay, so now we need to make sure we have the temperature final, all of them on one side. So to do that, let me add mass 1 times temperature final on this side, and we'll add it on the other side as well. And let me add mass 2 temperature initial. And we're trying to have like terms on both sides. There you go. Now let's cancel. So this one cancels. And this one cancels. So now we'll have mass 1 times temperature initial 1 plus mass 2 times temperature 2 initial equals mass 1 times temperature final plus mass 2 times temperature final. We're trying to find the final temperature. So we can factor out final temperature on the right side. It'll look like this. M1 temperature 1 initial plus M2 temperature 2 initial equals temperature final parentheses mass 1 plus mass 2. Now, since we're trying to solve for temperature final, just divide by mass 1 plus mass 2 both sides. Mass 1 plus mass 2. This will cancel. And I'm going to flip my equation because I want to have the temperature final on the left side. So our equation will say temperature final is equal to mass 1 times temperature 1 initial plus mass 2 times temperature 2 initial divided by mass 1 plus mass 2. Now the rest is just substitution, right? So let me use blue. I'm going to use the middle part of the page. Temperature final will be equal to mass 1. That was 200 grams. Now don't forget we're going to use kilograms. So we just move the decimal point 3 spots to the left. So that'll be 0.2 kilograms times, you know what, I'm going to need more space. So let me work here. There you go. Times temperature 1 initial, that was 50 degrees Celsius, plus mass 2, which was 100 grams, that is 0.1 kilograms, times temperature 2 initial, which was 20 degrees Celsius. And we're going to divide, let's fix it, there you go, by the summation of the masses, which was 0.2 kilograms plus 0.1 kilograms. There you go. That should give us the answer. Again, it should be anywhere in between 50 and 20 degrees Celsius. So let's try it out. 0.2 times 50 plus 0.1 times 20 will divide by 0.3. There you go, that looks okay. The answer is 40. That is 40 degrees Celsius. Which is within the range that we expected. And that is the final temperature.